My name is Andrea Virgin, Chair and CEO of the Center. We are an organization that helps people discover, grow, and share their creativity. And I'm here to help show that creativity can be a bridge between amazing ideas and people, and the technologies that fuel them. Now, you might be wondering why somebody who leads the Center for Creativity is up here today. One, I'm a bit of a warm-up so that you can really be prepped and ready for the incredible information that you're going to hear today. But before I answer more of the question of why I'm here today, I want to just see by a show of hands, how many of you in this crowd feel that you are creative? If I could just see a show of hands. Okay, this isn't bad. This is great. Okay, wonderful. I'm working with a great group. In addition to that, how many of you believe that you are experts in quantum or know a good bit of the base of the knowledge? Okay, wonderful experts in the room. But there's plenty of you out in the audience that are like me, a layman, somebody that is not a quantum physicist. And in order to prepare you for today, I thought it would be great, one of the great goals of today is to help you understand a bit about the basics of quantum, understand a little bit of the terminology behind it, understand a little bit about how it works, and an opportunity to understand the amplification and the opportunities that it presents. So in the spirit of creativity, we're going to lean into what allows for innovation. We're going to play around with a little bit of curiosity. We're going to allow you to have a little bit of fun and play. And then we're going to take the information that you learn, and we're going to allow that to be something that you foster a bit of imagination behind. So to start off, you guys have a little bag in front of each one of you. Inside that little bag are little bits of Lego. And by the way, I just found this out. Lego, plural, is just Lego. There is no S at the end. So I want you to take it out. There are 3 pieces in your bag, a yellow piece, a gray piece, and a white piece. So indulge me a bit. Everybody, hopefully you're participating. Now, there's supposed to be a 4th piece, so in the spirit of the center, please lean in with your imaginations and imagine a little black piece. So right now, we're going to go ahead and build one of the basic elements of quantum, and it is a qubit. And we're going to build what's kind of known as a quantum coin. Helps you to understand a little bit of one of the principles behind quantum, which is superposition. So you're going to take your gray piece and your yellow piece. You're going to put the base pieces together. That's going to be the base of your coin. All right, everybody looks like they're doing that. No, it doesn't matter which color goes on top. And then on the top of the coin, you're going to use a little round white piece, and that's going to go into the center of your coin. And that's going to represent the heads of the coin. Now imagine with your imagination, thanks to travel interruptions these days, we don't have it, but the black piece would have gone on the bottom, and that represents the tail of the coin. Now, please raise your coin in the air if you're done doing that. Wonderful. I mean, the fact that we're not quantum physicists, we just created a qubit, so congratulations to all of you. Now, this is where my experience stops. I am not an expert, as I said, on quantum computing, quantum technology, but there are amazing people in this room who are. I'm going to invite one of them up here to the stage, Mr. Marco Pistoia from ION. Where are we? There you are. Hey, Marco. Marco is the Senior Vice President of Industry Relations at ION and has been at the forefront of quantum technology and research for decades with JP Morgan Chase, with IBM, and now with IonQ. So I'm going to pass it along to him to explain about what this thing is, all the basics of quantum, and share a little bit more about the applications of it. Thank you.
Thank you, Andrea. So you guys have a qubit in your hand now. So, but what is really a qubit? Like it's a quantum particle that has been embedded into these new quantum computers. And why is it so powerful? It is powerful because unlike a classical bit that can be either 0 or 1, a qubit can be 0 and 1 at the same time. I know it's kind of like confusing. How can something be 2 things at the same time? But this is really what happens. What happens in quantum mechanics. Quantum particles are in a state of superposition. They can actually be in multiple states at the same time. So how does this help in quantum computing? It helps dramatically because suppose that you have to run a program. Suppose that you have 2 ways to go from here to your hotel, 2 routes, and you want to compute the best route. So technically, you would have to run this optimization program twice. One time you have to simulate the first route, the second time the second route, and there are many components that need to be taken into account, like the length of the routes, the amount of traffic, the weather, and many other things. Now, instead of running the program twice, which is what you would do on a classical computer, You run it only once on a quantum computer because you can put the two routes in superposition with each other. Now it looks like, big deal, you just ran a program, two programs in parallel, right? So something that we can do also with a classical computer. But if you have 2 qubits instead of 1, then the number of combinations is 4, because with 2 qubits you have 0, 0, 0, 1, 1, 0, 1, 1. And if you have 3 qubits, the number of combinations is 8. So it's growing exponentially, 2 to the power of the number of qubits. So right now, how many people do we have here?
There's 350 people in this room.
350 people. So if this were a quantum computer, we would have a computational power of 2 to the power of 350. Now, if you take your iPhone or your Android phone and you try to compute 2 to the power of 350, it's not gonna do it. It's a number that is so large that I think there is my friend Davide Venturelli sitting here. He's a senior scientist.
There he is.
Hi, Davide, a senior scientist and founder of the AI lab at NASA. Davide, what is the number of atoms in the universe? 2 to the power of 266 is the number of atoms in the universe. The computational space of our quantum computer here is 2 to the power of 350, which doesn't mean that there is a difference of about 100. No, it's because if you go from 2 to the power of 266, you have to multiply this number by 200 times to achieve the computational power of our quantum computer. And we're not that far away from reaching these numbers. At IonQ, we have a roadmap that hits this number in a couple of years from now. And we're talking about not only physical qubits, but a new concept called the logical qubits, which are like the perfect qubits with nearly zero error that will allow us to solve incredible problems in the pharma industry, in the banking industry, and so on. And I just wanted to mention another property of quantum bits or qubits, which is called entanglement, which allows the qubits to be related to each other. So this is a property, again, inherited from quantum mechanics. So if 2 qubits are entangled with each other, say 2 electrons, for example, any change that happens to one of the qubits is immediately reflected on the entangled element in the pair. And so you would think, okay, I changed these qubits. It will take some time before the other qubit sees the change because information travels at the speed of light or something like that. That's not even the case. It's immediate. So if 2 qubits are entangled and they are millions of miles away from each other, any change in the state of one qubit is immediately reflected in the state of the other qubit. And this is very important because when you build a program, you have correlations between variables, and you can encode these correlations using entanglement.
Thank you very much, Marco. Well, now I think all of you must just realize that you are now quantum physicists. You feel like you know a lot more. Thank you, Marco, for presenting that. It truly is, there is a lot of power in this room. 2 to the power of 350 of you have qubits now, larger than any quantum computer. It's fantastic, and larger than the number of atoms in the universe. So imagine, let's take the curiosity that we just built up. Let's take a little bit of the creativity and play that we just had, the knowledge we've just acquired, and let's play into our imaginations. We talked about, and Mayor James just mentioned the amount of things that could happen, the power behind quantum computing and what it could be applied to. Let's take our imaginations, and something that the center likes to do in some of its programming is do a little bit of a sprint, a little bit of a prompt. And we like to do this challenge called a what if challenge. So I'm gonna ask all of you guys in your bags have a piece of white paper and a pencil to take it out, please. And indulge me for 30 seconds, and I want you to ask yourselves, what if quantum computing could ... And I want you to write on your sheet of paper what you could imagine quantum computing doing. You just heard the number of computations that can occur just like that, the amount of data that can be processed, the problems that can be solved. So think about, perhaps a what if prompt. What if quantum computing could cure cancer? What if quantum computing here in the state of Florida, when there's a power outage after a hurricane, it would be really amazing if quantum computing could help solve the efficiency of getting our power grid back up. So just think about that question, take 30 seconds, write it down, and then I'm gonna ask 3 brave people to shout out what their what if prompt response was. And if you are not brave enough or the coffee hasn't set in, I'm gonna call 3 random people, so just be prepared. So I'm gonna go ahead and put it down. Let's take about 15 seconds and jot your idea down. All right. 5 seconds. Okay. So can I get 3 volunteers to shout out? Wonderful, I see it. Okay, great. All right, we'll start over here. Shout it out.
Break all nuclear codes and crypto wallet passwords.
Go ahead, Marco, you can say.
It is true, actually.
In about 3 years or so, right?
Yeah.
3 years, they'll be able to break RSA encryption. Amazing. Fantastic. Go ahead, hand up. To be able to predict the future human emergence of diseases in a human.
Yeah, this is a machine learning, like AI problem, like prediction, which is perfect for quantum computing. And quantum can also help dramatically model new drugs. So we will predict the diseases, but also the medicines, fortunately.
Fantastic. One last one over here. Oh, very good. Marco, do we have an answer for that?
Yeah, again, it's a machine learning AI problem, which is perfect for quantum in a couple of years with the roadmap that we will see in a moment. We will have a quantum computer capable of such computations.
Fantastic. Thank you, Marco. Well, in my last minute, thank you, Marco, for being up here and joining me today. I want to also thank the BDB for Quantum Coast Capital, Quantum Insider, and all of you here today for indulging me. I also want to commend the county commissioners, the city mayor, Mayor James, and everybody here who is behind this movement. This is truly an inflection point, and you're all here today, and I think you're all going to be able to take that quantum coin as a keepsake and remember you were here today. For the little papers, if you could leave them on your table, we'll gather them up at the break. I know that the facilitators today would really be curious about all of your answers. And I just hope I leave you here with just a last note, but to say, keep your minds curious. We live in a world that needs more imagination, not less. Be open to the flow of ideas here today. I hope I grounded you a little bit in the knowledge behind quantum, and hopefully that sets you up for a day against this amazing new frontier. Thank you all very much.